today the lecture on energy or internal energy. Before starting or delivering of our lecture on internal energy, I will repeat yesterday's lecture expressed on Joule's experiment. In our previous lecture, we expressed, derived, defined about Joule experiments, Joule apparatus. We have also defined the measurement of delta U upon delta V, keeping instant variable temperature as a constant, which is known as internal pressure of the gases. I mean to say, the measurement of internal pressure of the gases can be measured by using that is of Joule's experiment. Let us repeat once again about Joule's experiment, in which two bulbs are taken in the contact of hot water. Hot water acts just like a surrounding, and coupling of bulb to act as a system. In various conditions we apply on that is of Joule experiment, and finally we calculate the value of delta U upon delta V at constant T, that for ideal gas the change in internal energy with respect to volume is always equals to 0. I meant to say internal energy independent upon that is of volume but dependent upon temperature, that is internal energy, that is a function of temperature. It was experimentally verified by that is of Joule experiment. Today I will deliver on energy or internal energy in the series of various topics contents. Today I will deliver on energy or internal energy, which is very special, very special topics today. First of all, I have mentioned on that is of topic energy. I would like to define here, as you know, the capacity to do the work is known as that is of energy. Energy is expressed in the unit of joule, erg, calorie, and that is of kilocalorie. The whole energy of the universe one can add in the sum of two types of the energy, that is of a total energy of the universe one can write is that is of external energy EE plus that is of IE, that is of internal energy here. EE plus that is of IE, that is of internal energy. External energy further can be divided into its kind, as that is of kinetic energy plus potential energy. I meant to say external energy further the addition of the sum of two further kinds of energy, that is of kinetic energy, which is expressed as that is of half mv square plus potential energy. Due to mass, it will be expressed by that is of mgh, and nuclei it will be expressed by that is of minus zd square upon r. This kinetic energy occurs due to that is of velocity. I repeat once again, dear students, the whole energy of the universe can be written in the sum form, in the addition form, as that is of E total is equal to external energy EE plus that is of IE internal energy. External energy one can write into the form of further two types of the energies, kinetic energy plus potential energy. Kinetic energy which occurs due to velocity can be written as half mv square. Potential energy which occurs that is velocity or height, that can be written as that is of position. Potential energy which occurs due to the positions can be written that is of mgh, and nuclei direction one can write potential energy minus Zd square upon R, and there is no contribution, no much more contribution of external energy in thermodynamic here, but there would be very extreme role and contribution of that is of internal energy. So that I will deliver the lecture on that is of internal energy. Internal energy, it must essential to remember, we have to write down important feature regarding that is of internal energy. What does internal energy, what is its role, How does it act to define various parameters like state variables, temperature, pressure, volume, and how internal energy is related with first law of TD and with the collaboration of other thermodynamic quantities like enthalpy, entropy, gives free energy. Let us focus, let us write down some important features and its derivation and origin of that is of internal energy. First of all, that is of internal energy. Internal energy is mainly concerned with the mass of the system here. First postulate I would like to define here regarding to the information of internal energy. Internal energy developed by that is due to mass is known as, this energy is known as internal energy, or I mean to say the energy which is mainly concerned the mass of the matter is known as internal energy. It is derived, it is the origin due to translation, that is of rotational and that is of a vibrational. Next point, next postulate regarding to that is of internal energy, some series of various postulates regarding to that is of internal energy. What does internal energy wants to say here? First of all, it is mainly concerned the mass of the matter. Second one, it is derived, it is the origin, translation, rotational, vibration, degree of freedom of the molecules here. Third one, that is it is also occurs in nuclear reactions also. Fourth one, it is symbolized by that is of du or that is of dE, du or that is of dE, symbolized by du or that is of dE. Next one postulate, in cyclic process the value of its value of integration du will persist as that is of 0. Since internal energy that is a state function, hence one can write down its symbol, it will be symbolized by that is of du or that is of del u or dE or that is of del E. D indicates, D denotes very infinite, that is of infinitesimal change, and del denotes that is of finite change in internal energy. Another one symbol dE or del E. Next one, that is of, it is related, it is the role in the first law of thermodynamics as delta Q is equals to du plus delta W. These were the fundamental features, important point to define about that is of internal energy. It is mainly concerned with that is of delta Q is equals to du plus that is of delta W. In compact form, let us repeat, internal energy is mainly concerned with the matter and also involved in that is of nuclear reaction, state function, cyclic process. Its value becomes as that is of 0, and that is of it is related with first law of TD, delta Q is equals to du plus delta W. These were the information, these were the important features of that is of internal energy. Now let us proceed this topic of B.Sc Part II in Unit 1. In the series of various contents here, let us proceed here. Next topic, internal energy and its change at that is of constant volume. In the series of various topics of B.Sc Part II in Unit 1, let us proceed the next topic. This topic is also very special topic. The topic that is internal energy and its change at constant volume. This whole title will be summarized as that is of CV. On solving this title comes out the value of CV. This CV is known as heat capacity at constant volume here. To define, to derive, to express about the title, its derivation, let us firstly start. We know, let us assume internal energy that is a function of temperature and that is of volume here. Here U, that is a fundamental thermodynamic quantity, it is depending upon that is of two state variables such as temperature and that is of volume. First 3D equation will be written by equation number 1. It's a final 3D equation one can write into the form of, by using the conceptual of state and path functions. du is equals to delta U upon delta T, keeping volume state variable as parameters constant, dt plus delta U upon delta V, keeping state variable temperature as constant into that is of dV. Here du state function, path functions, path function, state function. Similarly, path function and that is of state function. So using the basic conceptual of state function and path function, I am writing here its exact TD equation in the equation number that is 2. Now let us proceed, let us derive further equation number 2, the quantity which we are going to solve. Firstly, that is of tick mark. The quantity which we are going to solve, let us, that is of tick mark, that is of du, and that is of tick mark here. Du, in order to solve du, that is I am using here, that is of first law of TD, delta Q is equals to du plus delta W, du is equals to delta Q minus that is delta W. Code down equation number 3 also. Now put down 3 in, that is of 2. This equation number, we have already coded it, that is of equation number 2 here. So du will be written here, delta Q minus delta W, rest quantity will be the as such here. Since we know that delta W is equals to that is of P dV, then from equation number again that is of 3 here, delta Q, you know also write down that is of direct also. This one equation put down, that is of this one equation, delta Q will be as such, delta W is equals to P dV, UTV dt will be as such plus UVT dV, that is of dV. When V is equals to constant as condition, V is equals to constant, now we apply volume keeping as a constant as conditions is here, it's change at constant volume. So now we introduce, we apply the given condition, V is equals to constant, dV is equals to 0. Another one change, that is now heat, delta Q becomes is equals to delta QV. So delta Q, we put down the value here, delta Q will be replaced by delta QV minus P into dV is equals to 0. This term will be remains as such, dV is equals to 0, delta QV, this thing is equals to 0 on delta U upon delta T constant V into that is of dt. CV is equals to delta QV when is divided by that is of dt is equals to delta U upon delta T constant that is of V. Amazing quantity we have here, very specific physical quantity we have here, that is in order, suppose I am taking here, in order to define that is of a system, now we are going to define that is of a CV. How will you define that is of CV? That is of, you know here, to increase the temperature of dt, the absorbed heat by the system, delta Q is equals to du, is known as heat capacity at constant volume here. Once again, dt is similar to delta T, delta QV is equals to that is of du here. Suppose we assume, we consider here as a system here, and we define CV on the behalf of the system to fill 1 mole of, that is of 1 mole of gas. To increase the temperature of this system is filled 1 mole of gas. To increase the temperature dt, the heat given or absorbed, delta Q which is equals to that is of du is known as, is the ratio is known as that is of heat capacity and that is of constant volume, and its dimension, its unit will be expressed as that is of heat upon temperature, dimension, energy upon that is of temperature, calorie upon that is of temperature for 1 mole, calorie mole inverse temperature inverse here. Once again I would like to define here by applying here that is of internal energy at constant volume here. Try to understand once again here, keeping volume as a constant in fundamental internal energy, its derivation U, that is a function of T and V, TD equation, using that is of first law of TD, delta Q is equals to du plus delta W, du here, du is replaced by delta Q minus that is of delta W here, delta W replaced by that is of PdV, PdV here, dV is always present here, rest quantity will be as such here. Now we apply 3 important changes, V is equals to constant, so dV is equals to 0 here. Now delta Q, students generally forget to write delta Q, they write as such, they don't write V below, that is of delta Q, so it is essential to write in which conditions the system is undergoing. It is also to write the state variable parameters also. So delta Q will be replaced by that is of delta Q, because here you know that we are going to define internal energy at constant volume. So on solving this one, finally that is the results come out here. When a system to increase to be filled 1 mole of gas to increase the temperature of this one system, the absorbed heat delta Q is equal to du, and its divisible by that is of temperature is known as heat capacity at constant volume here, and its unit will be dimension will be expressed that is of calorie per temperature, or energy per temperature. A unit will be expressed for that is of calorie per Kelvin here, and for that is of 1 mole calorie mole inverse, or that is of Kelvin inverse. It is the definition of CV here. Next topic, that is of enthalpy, or that is of heat contents. Next topic in the series of various topic including enthalpy of B.Sc Part II Unit 1 Thermodynamics, we will deliver the important lecture on that is of enthalpy, which is also known as that is of heat contents and symbolized by dH or del H. We will discuss on this topic our lecture tomorrow. Thank you very much.